Human behavior is just messy. It's unpredictable, it's constantly changing, and honestly, it's all over the place. Every single day, billions of decisions are being made about what to buy, where to work, and how to invest our money. So how on earth do we make sense of it all? How do we take this entirely unpredictable mess of human economic behavior and actually measure it, let alone predict it? Well, it turns out we have a remarkably powerful toolkit designed to do exactly that. And that's exactly what we're going to unpack today.
So, welcome to this explainer. Today we are demystifying econometrics. Now I know, that word can sound incredibly daunting. It sounds like something strictly confined to the dusty halls of academia, right? But actually, scratch that. It is genuinely one of the most practical, fascinating lenses we have for viewing the real world. By the end of this, you're going to see exactly how highly theoretical ideas are transformed into actionable reality.
Okay, here is our game plan for today. We're covering 1. What is econometrics? 2. The ingredients of econometrics. 3. The engine, which is regression analysis. 4. Building and testing models. And finally, 5. Real-world applications. All right, diving right into Section 1, what is econometrics? Let's figure out what this intimidating term actually means. Basically, econometrics is the ultimate interdisciplinary mashup. It's the integration of economics, mathematical economics, and statistics. But why do we need to combine these three? Well, the whole goal here is to provide actual hard numerical values to the parameters of economic relationships. Think of it like this. Basic economic theory tells us that when the price of something goes up, the demand for it goes down. Okay, that's a great concept. Mathematical economics then turns that concept into an equation. But econometrics, that's what steps in, takes real-world empirical data, and tells us exactly how much demand will drop if that price goes up by, say, $1. It gives the theory its actual numbers. To really wrap our heads around this, we need to contrast mathematical modeling with economic modeling. Mathematical modeling is exact. It's pristine. If you have an equation, a specific input is literally always going to give you the exact same output. It's a closed, perfect system. But let's be real, the world isn't perfect. Economic modeling uniquely accounts for random stochastic behavior. It openly acknowledges that we humans aren't perfectly rational walking equations. We do weird, unpredictable things all the time. And I absolutely love this quote from our source material. When econometricians build a model, they put in all the variables they think are relevant. But they know for a fact they can't capture every single thing. So whatever is left over, the rest of the variables, are literally dumped in a basket called disturbances, which are random variables. This basket of disturbances perfectly captures the messy reality of human life. It's basically the statistical equivalent of saying, yeah, and then some random stuff happens that we just can't control. Moving right along to Section 2, the ingredients of econometrics. Let's look at the raw materials we need to bake this econometric cake. So we've got 4 main types of data here. First, time series tracks data period to period, kind of like watching your monthly income over the span of 10 years. Then we have cross-section, which looks at different individuals or agents at one single point in time, like a snapshot of what 100 different families spent on groceries just today. Panel data is a combo of both. It repeats surveys of those cross-sections over a period of time. But the one that is a real game changer is the dummy variable. It is so clever because it takes qualitative traits, like a person's gender, their religion, or whether they simply like or dislike a certain taste, and translates them into measurable ones and zeros. It literally forces our messy qualitative reality into a hard quantitative format so the models can actually process it. But we do have to be incredibly careful here. Gathering all this data can introduce a massive headache known as aggregation bias.
If we carelessly combine microscopic data into macroscopic groups, like, say, summing up individual incomes just to get one total, or lumping daily data into a giant annual figure, or grouping totally different geographic regions together, we can accidentally bake fundamental errors right into our data. If we aren't careful with how we lump things together, our whole model's going to be flawed before we even turn the statistical engine on.
And speaking of that engine, let's jump to Section 3, the engine, which is regression analysis.
Before we get into how regression actually works, let's do a quick mental reset. Think about this question for a second. Does the model generate the data, or does the data generate the model? The correct answer, at least from an econometrician standpoint, is the first one. Ideally, there is a true pre-existing model out there in nature. It's this invisible natural law of how the world works, and that invisible model is what generates the data we actually observe around us every day.
Which brings us to the literal translation of the word regression, which is moving in the backward direction. Because that natural model is totally invisible to us, econometricians have to act like detectives. They collect the data that the world leaves behind like clues at a crime scene, and then they move backward. They use statistical techniques to walk backward from the visible data to uncover the unknown causes and mathematical parameters of that hidden natural model.
Let's see how this all builds into a highly structured procedure. You can't just throw a bunch of random data into a computer and hope for the best. First, you have to state the exact problem. Then, carefully choose your variables, collect the right data, specify the mathematical shape of your model, choose a fitting method, usually something called the least squares method, and finally, fit the model to find those unknown parameters. Here's the catch, though. If you mess up step 1 or 2, step 6 will give you a beautiful, mathematically perfect answer that is completely wrong about reality. All right, section 4, building and testing models. Econometrics is definitely not a write one equation and you're done kind of deal. It all starts right here with our inputs. This is the whole shebang we've talked about so far. Our economic theories, the mathematical models we've specified, the statistical assumptions we're making, and of course, the raw data we collected. This is our foundation.
Once we have those inputs locked in, we feed them straight into the estimation process. This is where the heavy statistical lifting takes place. We estimate the parameters of our variables, we calculate our confidence regions, run hypothesis tests to ensure everything is statistically significant, and we generate graphical displays to actually visualize what on earth is going on. And that intense estimation process finally spits out our outputs. These are the final predicted values, the actual numerical answers we were hunting for in the very first place.
But hold on, we are absolutely not done. The most crucial part of this whole thing is diagnosis, validation, and criticism. Econometrics is a continuous iterative cycle. You have to rigorously take your outputs and use them to diagnose and criticize your original inputs. Did the data violate our initial assumptions? Does the output actually make logical economic sense in the real world? If the answer is no, you have to modify your inputs and run the whole thing all over again. You're just constantly, relentlessly testing your model against reality.
Which leads us perfectly into section 5, real-world applications. Let's zoom out from all this microscopic math for a second. How does applied econometrics actually impact our daily lives? Well, this is where those theoretical equations turn into massive, actionable tools. Financial institutions use applied econometrics to forecast future stock prices and interest rates. Marketing firms use it to dissect consumer behavior so they can price their products for maximum profit. Labor economists rely on that panel data we talked about earlier to figure out exactly how a minimum wage hike will impact jobs, or how a college degree mathematically translates to lifetime earnings. And governments?
They rely on these exact models to evaluate massive fiscal policies, predicting inflation and GDP growth long before they actually pull the trigger.
To put that into perspective with a concrete example, just look at real estate. If a town announces a brand new transit hub is being built, an econometrician can build a model proving that houses near that new development will increase in value. Pretty obvious, right? But they might also predict that houses near an older market across town will actually decrease in value. Why? Because the new market shifts supply and demand, suddenly creating more sellers than buyers in the old neighborhood. It's literally a toolkit for predicting highly localized, real-world outcomes based on shifting variables.
So, as you've seen, Econometrics takes that messy, unpredictable basket of human disturbances and forces it into a highly structured, predictive engine. It's proof that the world isn't just random chaos. There really are invisible models governing the flow of capital, labor, and resources all around us. Which leaves us with this final thought to ponder. If econometrics is the mathematical lens of reality, constantly moving backward to find the truth, what invisible model and what hidden patterns is your own daily data generating? Thanks so much for joining me on this explainer, and remember to keep questioning the data around you.